No, they're not the same. But the central tendency, mean, median, and mode are not good enough to tell us anything interesting. But central tendency cannot tell them apart. These things that we calculated yesterday, that we got pretty good at calculating yesterday, can't tell us anything new about. They can't distinguish those two very different sets of numbers. They can't do it because they gave us all the same. What that means that we need something better is that we're going to have to find something else. They'll describe this data and tell us, well, how are they different? Because these are saying they're all the same. If you didn't have this, and I said Equator Town has mean, median, mode temperature of 79, and Texasville has mean, median, mode temperature of 79. So therefore, I should conclude that they're identical. They're like in the same spot. They're the same temperatures. But we know from looking at the actual temperatures that they're very different. And we want to know a good way to measure that difference. You know one way, but I claim it's not a very good way. One way is by looking at range, which is what we did yesterday, a spread. One measure of spread is range. Why do you think that range really isn't a good way to describe how all of the data is spread out in a set? Why do you think range isn't very good at telling us how all of the data is spread out? Think about what range is. How do you figure out what the range of a set of data is? Well, how do you calculate the range? Lily? You subtract the highest point from the lowest point. So you find where the endpoints are. But does that tell you about anything in between?
No.
It doesn't tell you a darn thing about what's going on in between those two numbers. All it does is say what the biggest number is and what the smallest number is. And if you subtract them, you get a big distance. You get a distance of something. You don't know what's going on in between there. You could have all the numbers, all of the data, like all the data could be moved and shifted down to like one end of it. You have a bunch of stuff on one end and just like one guy like way out here, like an outlier. That could really that could give you a huge range, but there's not really much spread. Things like that. We want a better calculation. And that better calculation is called standard deviation. That better calculation is called standard deviation. Standard deviation is the following. Standard deviation is just the average distance each data point is from the mean, or from the average. So we're going to figure out how far every individual piece, on average, itself, is away from the mean. We're going to get a calculation of that. Standard deviation has a formula. It's relatively complicated. Complicated enough to the point where I'm not going to write it down for you. You can come see it if you'd like. I'll show it to you. It's just got a lot of different variables going on. I don't want to get you like seizing up and like panicking before we even get into it, because it's not hard to work with. It's just it looks intimidating. We will say that the symbol for standard deviation is the Greek letter sigma. It's like an O with a curly thing on top. Its name is sigma, and that's the symbol for standard deviation. Its name is, it's a lowercase sigma. That's the name of that symbol. And that symbol is the symbol we use in math and statistics for standard deviation. Okay. As I said, there is a formula that we can look at. We don't really use it that much. We're going to just figure out how like through like Moore's operations it would work. And it's 6 steps. Okay? It's going to be 6 steps, and I'll work you through how to use this formula. Step 1, in order to find the standard deviation, we're going to first find the mean. of the data. You're first going to find the mean, find the average. What we did yesterday. And it actually has a specific symbol as well that we'll see when we start looking at our graphing calculators. Its symbol is an X with a bar over top of it. In fact, it's called X bar. It's not real complicated. It's the symbol for mean. You see an X with a bar over top of it, that's saying this is the average of some data. Okay. Step 2, once you know what the mean is, we're going to go through and we're going to, for each data point, we're going to subtract the mean from each data point. So if there's like 5 numbers that we're going to find the standard deviation of, we'll take the mean of those 5 numbers and we'll go for each one of those 5, we'll subtract the mean. So we'll get 5 new numbers. Okay, that's our second step. Once you've subtracted from there, then what we're going to do is, then we will square each new number. Step 4, once you have those squares, now we're going to, now life gets a little bit easier. Now we're going to add them together. Add the new numbers together. Once you've added the new numbers together, I said we're going to find an average. If we add all the numbers together, what do we divide by? We're finding an average distance. If we add all these numbers together, what do we have to divide by? You're finding like an average or a mean. What do you divide by? Francesca? How many numbers there are. So we'll divide now. Step 5 is divide step 4 by how many numbers there are. Divide by the number of data points. If you started with 6 numbers that you find the standard deviation of, you'll divide by 6. If you started with 10 numbers that you're trying to find the standard deviation of, you'll divide by 10. If you start with some other number, you'll divide by that other number. It's however many numbers you start with. That's what you're going to divide by. Now, last and final step, you do once you've got this and you've divided by how many there are. Now, last thing is we're going to find the square root. The square root being the opposite of squaring. The square root, as a reminder, is that symbol. We'll find the square root. And once we've completed this, we'll have completed all the steps that the formula would tell us to do, and we'll have found the standard deviation of a set of numbers. What's the first thing we need to do to find the standard deviation? What's step 1? Find the mean. And Sarah? Sarah, find the mean. So, right now, take your calculator, or by hand, whatever you want to do, and find the mean of those 5 pieces of data. Take the mean of the 5 numbers and subtract them from each of the data points. And we should get the following. So we'll square, or we'll multiply negative 5.2 by negative 5.2 and get a new number. It should be what? 27 point square negative 5.2. So negative 5.2 times negative 5.2. And that's 27 point, was it 04? and I'll multiply negative 0.2 by negative 0.2 and get a new number. And do the same for these last 5. And when you finish squaring them, you get these numbers. Again, we're multiplying them by themselves. At this point, you should not have any negative numbers anymore. You may have had them before, but you shouldn't have them now. If you got negative numbers, that means your calculator tried to lie to you by typing in a negative and it's not recognizing something correctly. Make sure that if you're getting negative numbers, that they actually should be positive. Okay?